Our ideal signature, therefore, is 2 jets, a lepton, and the missing transverse energy corresponding to the produced neutrino.
That way, I can use the arctan function of Excel to sort the points based on the angle that they made with the horizontal axis.
Set an energy threshold of 6.24 times 10 to the negative 8 GeV. This eliminated a lot of the background energies. Well,
for events that had muons, they're often more difficult to determine where the which energy clusters correspond with which particles.
Because the muons are so much heavier than the other particles, they tended to follow a straighter line.
I also would fit the same muon stub, the muon stubs to the circles that were from the original actual tracks that we had from earlier.
Which were mainly focused on isolation of the tracks and clusters, but they also required some information about pseudo-rapidity and momentum of each particle.
The second thing I needed to do was calculate the location of the centroid of the jet, which had to be done in spherical coordinates. So
as you can see in this plot, there is a gap near the origin, and that gap relates to where the B core decayed through.
Calculated the transverse energies, and assuming that all the energies would sum to 0, we could assign the remaining, or the vector sum of the energies.
The semi-leptonic high PT triggers for the W boson decay. 26,802 events were accepted, giving an overall trigger of 0.268 and overall.
To find the transverse energy in tower occupancy based luminosities for each one, then
Everything below a transverse mass of 25 GeV, and everything with an MET significance between 1.8 and 2.2.
I was able to use a linear scale factor to match the two and estimate the real data from just the Monte Carlo.
So then, based on this, using the exact same equation Alan did with the cross-sectional luminosity that I got from Vishal, the acceptance rate and the efficiency that I got from Alan, and I used that to find the signal region QCD fraction was 6.3%, and it came
having a bin that's either as close to as a high ratio of signal or background, I can isolate the events clearly as signal or background. What I did is I took the natural log of the likelihood function, and then on top of that, I used Stirling's approximation, where the natural log of n factorial is around n multiplied by the natural log of n minus n.
As my computer was not able to effectively generate more than 10 billion pseudo-experiments in a timely manner. The 10 billion pseudo-experiments took 3 days to generate and calculate the likelihood for, and the next number that I was going to be able to do, 100 billion, would have taken a month.
Solving for that, one can see that we found the parameter space for the mass of the pseudoscalar peaks and for tangent beta, but there's an imaginary term in the lower bound for tangent beta.